Alright, so here was my little template to change numbers. And now suppose I have, and here I just have a 3x3 chi-square template. So suppose I made that. Now this one is set up so that it has the is a number or is number command in there, so that I can just blank something out, and it doesn't give me an error. Now that would be bad data if I did that, but and I don't remember what that was. We'll just call it 45. But there's my original data, my expected. Here's my z squared over the standard error, so B3, so that's up there, minus B9 here, quantity squared divided by B9, the expected number. And again, I have the is number in there. And so, if I have that, well, I can take this whole thing and highlight it, and I'll copy it. And the nice part is, if I just come over here and paste it, so I'll click there and say paste, there it is. And I'll shrink this down a little bit so we can see, well, not quite everything. Bring that in there, we can see all our numbers. And so there we have our numbers. Oh, I think I had dollar signs on something here. So this, we've got to be careful here on this. So that's looking in the right place. H2 though, so H2 but D6. See, so it's looking over here. I do have to fix that. I forgot about the dollar signs. So that was, remember what that is. It's taking that proportion times that number there, and so change that to the J6 and hit enter, and pull that down and pull that over, and there I've got it fixed up again. Everything adds up, and I can go back here and check, is that correct? Yeah, 150, 30, 13, 6, and so forth. So yeah, you got to be a little careful with copy and paste, because I did have some dollar signs in there, but now I fixed it all up, and so there's my data. And so what I can do is I can go here, I put this next to my template, and in my template I'm not going to need that column, so backspace and get rid of that. I don't need that row because I just need two of them. Backspace, get rid of that. Notice everything still works because I had the is number in these two spots. But now, instead of that 15, what I want to do is put in that number. And so I'll just say equals, and I'll click on that number. Okay, and hit enter, and then I can copy that down here, and I can copy it over there. And now you see I have all my data right in my template, and there you go, there's my p-value of 0.067. So notice if I have a total of 200 participants, which seems like a lot, but 10% of them did the questionnaire and 90% the actual mice, it turns out that these data would not convince me something different was going on between those two proportions. I would say, well, actually there's a almost 7% chance that these two proportions actually came from the same population of tendencies, I guess would be the way to put it. And so we don't know that either of them is the correct proportion. It's probably neither of them, but we would have to say that, well, we don't think they're actually different. We don't think that these cases are independent. I'm sorry, we don't think they're dependent. We think they're independent. That, well, it doesn't matter whether somebody did the questionnaire or the actual mice, their tendency is the same. Now, it doesn't look like it probably is, you know, from what we see up here in those two proportions, but our p-value down here says about 7%. And now, but the interesting thing is, I think if we go here to 0.5, so 50% each, all of a sudden our p-value drops drastically by a factor of 10, and we're at 0.6% or 0.006. So we're well below the 0.05 range there. So if we had done this experiment with 200 participants and 50% did the questionnaire and 50% did the actual mice, and we did get these proportions that we see up here, then we would say our data supports the idea that there is a dependency here. In other words, people act differently in filling out a questionnaire than with the actual thing. And in this case, in the actual thing, they are more likely, the 83%, to sacrifice the one for the many, which is just kind of an interesting thing, is that if this is the case, that's what we found. So we can change these numbers over here. You know, I could take this up to 1,000, 2, 3, 1,000, and with 50-50 now we're down to a really, really tiny p-value, basically 0, 10 to the negative 9th. But again, you know, we could change the, oops, not that one, we want to change this one. Say that was 90%, and only 10% did the actual mice. What happens then? Well, it's a much bigger p-value, but it's still very tiny. And so if we had 1,000 people in our study, which is definitely hundreds, and even if 90% of them did the questionnaire and only 10% did the actual mice, if these were the proportions, we could actually see a very tiny p-value that would be good. We could truly say there is a difference between filling out the questionnaire and actually working with the mice. Okay, so that's how we can use this. That's how we can use our template once we've made it, and we can use all that to then study different possibilities for our proportion here and our total number there.